Alright, so in this video we're going to talk about the relationship between derivatives and concavity. So I'll just start by stating that relationship. So there's a nice relationship between the second derivative, which we call f double prime, and concavity. And here it is. So assuming that the second derivative is not 0 at a point, then the second derivative is positive if and only if f is concave up at that point. And the second derivative at a is negative, less than 0, if and only if f is concave down at that point. All right, so this gives us an algebraic way of finding concave up and concave down. Let's look at an example. So consider the function f of x equals x cubed minus x. And we want to ask the question, where is f of x concave up? So we could look at this graphically. We're going to look at this with the second derivative. So we're going to take the second derivative. First derivative is 3x squared minus 1, and second derivative is 6x. So the second derivative is 0 when x is 0. So before and after 0, that's when we want to determine whether it's concave up or concave down. So the second derivative is positive when x is greater than 0, and the second derivative is negative when x is less than 0. Therefore, it's concave up when x is greater than 0, and it's going to be concave down when x is less than 0. Another way to put this is it's concave up on the interval 0 to infinity. Let's look at another example. So in this example, we want to identify the intervals of concavity for the function g of x equals 3x to the fourth minus 4x cubed minus 2. All right, so we're going to use the second derivative. So first thing we're going to do is find the first derivative. So 12x cubed minus 12x squared. And then the second derivative, 36x squared minus 24x. We want to figure out where this second derivative is 0. So if I factor the GCD out of this, I'll get 12x, leaving behind 3x minus 2. So this is 0 when x equals 0 and when 3x minus 2 equals 0, or x equals 2/3. So those are my zeros. Let me do a sign diagram to see what the derivative, the second derivative, is doing before and after these zeros. So at 0 and 2/3, it's 0. F double prime is 0 here. And now let's put in some points, some test points before and after 0. So put in negative 1 and 1/3. And then we'll put in 1/3, which is before 2/3, and positive 1 into our second derivative. So our second derivative was 36x squared minus 24x. That results in 60, which is a positive number. Putting in 1/3, we'll get 4 minus 8, which is negative 4. That's a negative number. And then if we put in 1, we'll get 36 minus 24, which is 12, which is a positive number. So its second derivative is positive before 0, negative after 0, and positive after. So it's going to be concave up where the second derivative is positive, concave up on the interval negative infinity to 0 and 2/3 to infinity, and f is concave down on the interval 0 to 2/3. All right, I hope you found this video useful.